Okay, practice problem 510 millimeters. Parts origin located as indicated, so the top circle and the bottom of the part. And then lines, center line circles, sketch fillets, convert entities, trim. Not seeing where we're going to use those, but I'll keep them in mind. Extrude boss, extrude cut, and the planes. I really don't see a plane on this, so after we take the volume, I'll probably add a plane for geometry to put a hole through the top or something. Let's go with a new part millimeter. All right, we want to draw on the top plane. So again, the isometric view, the front plane is going through the hole, the right plane bisects the part, top is the bottom, or top is the bottom of the part. So let's go ahead and get into our sketch, and we'll draw the first circle. All right, let me zoom that up a little bit. So we have a radius of, or a diameter of 8. So let's go ahead and figure that one out. And then based on where this is located, why don't we do this the hard way and draw the 3 circles. And then we'll go back and create a center line, and because this is equilateral triangle, we should, well, maybe it's not. Let's say these 2 sides will be equal, and this side will be long, so we would have to verify those. All right, but that gives me pretty quickly my geometry, and we're going to select, control select, and set equal. All right, so the outside geometry, we can go to the angle, come back to the continuous tangent, and we'll continue to drag those lines, go back continuous, and just keep in mind that you can always switch back to the tangent arc, back and forth between line. I think dragging back to that start point is about as efficient as it gets. So our arcs should all be the same, so radius of 15. And then the other thing that we're going to, I was looking to select equal. So let's go back and make sure that they are all equal. Nothing in the existing relations, and since I got rid of the box, we will come back over to the feature, to the property manager, and set those arcs to equal 15. All right, so let's take a look at what happens when we start to drag. All right, so that one's not tangent. That one's not tangent, and if we went that way, yeah, that one's looking tangent, but it's, let's go ahead and add a couple of tangents since we don't want that to get too messed up. All right, so we should be able to take the center points. Interesting. So somewhere in there, we got an extra relation. So let's see what error it generates if I make that coincident. Looking for the center point and the center point of the circle, coincident. So I don't really know why it was moving that way, but once we start adding the relations, that's going to give us our geometry. All right, so I think I have everything. 60, 75, the outside. Don't see anything too different there, so let's go ahead and extrude. And we have a blind thickness of 10 millimeters. Make sure it's going the up direction. And then we'll open a sketch. for the circle. All right, again, we're just going to go right to the inner and the outer. And we have 32 and 21. Okay, select, control select, those are vertical. And because the edge is actually laying in the sketch plane, that will give us our geometry. All right, so then I can go to the quadrant down to the edge and look for that inference line helps, and then bring it back up to the quadrant. All right, so that gives me fully defined. I have 3 regions, and we can start building that inside geometry. So the plane, the place that we could use the plane is to offset from that face 30 and then go back the 85. But I mentioned before that inside of the feature we can do the same thing with the from, and we'll offset that from 30 millimeters and see which way it goes. And then the blinding condition will be the 85, and then we have to tell it what geometry to go with. All right, so the offset then, if we reverse, nope, that wasn't it. If we reverse, that looks a lot better. Oh, and since the front only has that ring, well, we can't really do that offset anyway. So let's just go from sketch plane, and let's see, how do we want to manage that? So from our geometry, there's a couple ways to approach it. So let's go back to the 30, and if let's see if it gives us a 0 thickness if I build that. No, but it did make it 2 solid bodies. All right, so that's not a deal killer. We will come back into the sketch and extrude, and the contour is going to be that one and that one, reversing the direction and up to surface. All right, and then when we pick the endpoint, that will bring it back. All right, so where we could use the plane, we would end up having to do kind of the same thing because this squared off geometry doesn't extend out, is just going into that that front face, going to the reference geometry plane, we would create an offset plane 30 millimeters and go ahead and hit OK, and that does the same thing as the from and the basically the from and the to. So just keep that in mind, that we may be able to generate that geometry out of the feature, as opposed to having to always create the plane. But certainly the plane would work as well. All right, so our volume, let's get that into view, 105,501. And we are at 105,500, rounded up 501. All right, so that's pretty good. Then to put geometry, so like the whole wizard, kind of added that into one of the optionals. So this is an optional if I needed geometry, or maybe I needed geometry around the outside, we would be able to open up a sketch on that in face. Well, since I created the plane, I don't necessarily need the plane, but I can come back and use that that sketch. And if for some reason it needed to be off at an angle, then we would be able to control that that angle with the sketch as a clocking mechanism. So let's go half 45, 22.5 degrees. All right, so the first plane that we'll add, I'm going to do this as a plane index, is that we can pick that surface and that point, and when I go into the reference geometry and set the plane, it is tangent and at that point. If I didn't select the point, then it kind of bounces around. We could probably do the second reference as as the top plane, and then it would be perpendicular or parallel. Does it give the angle? All right, so it does give the angle. So if I went to the 22.5 and flip the offset, I should have the exact same thing as going through that point. All right, so it is combinations. The nice thing about the sketch is it's a visual representation of what's going on here. All right, so I'm going to go back to parallel and leave that one, and then we're going to do the same thing again and maybe in reverse. All right, so the first reference then is tangent to the surface, and the second will go to the line, which forces it into that geometry. If I did not create that sketch, then I would need to pick, let's do the right plane this time. And if we go to the 22.5, then we're going to have that more critical angle rather than, let's see, we're off of the right plane, so the 22.5 this way plus, yeah, that's too much math. Let's go with the 90 minus 22.5. And that puts it in the same orientation as going through the point. But again, different combinations, the way that you see it and the way that you can make that approach. And what we end up doing then is, with that plane highlighted, we can go into the hole wizard. And I don't know, I want to put let's put a tapped hole. We'll stay with the M3 by 0.5 just because it's fun. And we're going to select the plane that's on the angle, and wherever I put a point, that's going to be a hole. So we're going to, that did not go vertical, so let's go back, and there we go. Want to make sure it's vertical, and then we can put in some distance back to the shape. So let's go 45. All right, so that's going to give us the geometry. If I decided that needed to be, did need to be a counter bore, we would be looking at probably, let's go with a socketed cap screw that looks a little bit deep. Let's see if we can find the M3 again, and we'll place that. And that kind of figures out the fish mouth or the geometry that we have created. All right, so I'm just hiding the plane, the extra geometry. You know, again, this is just an example of how to get geometry onto a cylindrical surface in addition to our standard geometry.